Solving problems on triangles other than the right angle triangle exposes the weaknesses of the Pythagorean theorem and the trigonometrical ratios. This is where the sine rule and the cosine rule comes in. Looking across the four triangles here, we would see that there is no way the Pythagorean theorem nor the trigonometrical ratios can help us because none of these four triangles is right. First, we are going to consider the sine rule. The sine rule states that in any triangle, the ratio of A to the sine of A is equal to the ratio of B to the sine of B, which also equals the ratio of C to the sine of C. This is considering a triangle A, B, and C. Of course, the lowercase letters are the sides, while the uppercase letters are the angles. But when do we use the sine rule? We use the sine rule when we are given the following information. 1. If we are given a side and two angles, or if we are given two sides and an opposite angle. So this is the sine rule. Let's consider the cosine rule so we would be able to compare. Here is the cosine rule. The cosine rule states that in any triangle A, B, C, A squared is equal to B squared plus C squared minus 2BC cos A, or B squared is equal to A squared plus C squared minus 2AC, the cosine of B, or it can be expressed as C squared equals A squared plus B squared minus 2AB, the cosine of A. When do we use the cosine rule? We use the cosine rule when we are given three sides of a triangle, and secondly, if we are given two sides and an included angle. Now, going by that, let's look at these four triangles and see which of the two rules will be most appropriate. The very first one here, we can see that we've got the side B, lowercase b, because that's the side facing angle B. We also have the side C, and we are given the angle at C. So it's obvious that this first triangle can be resolved using the sine rule. Because we've got two sides and an angle, and this angle is not an included angle. If the angle was here at A, the sine rule would not have been appropriate. So the sine rule is going to work here. So I'm going to write sine rule. So it's going to be very easy for me to use the sine rule to obtain either the length of the side BC or either of the two angles. Let's move to the next one. We can also see here that we have two angles and a side that's opposite one of the given angles. So the sine rule is also going to work. So I'm going to write sine rule here. Now let's move to the third one. Now we can see here that we've got two sides and an included angle. The angle 120 here is between the sides AB, which is 5 centimeters, and BC, which is 8 centimeters. So the cosine rule is going to help us resolve this. Finally, this triangle has three given sides. So we can see the cosine rule is also going to work here. So this is how we can determine which amongst these two rules, the sine or the cosine, would be applicable to solving problems in a triangle. So let's solve. So this is the first triangle. We've got a triangle ABC. The angle at B is 42 degrees. AC is 12 centimeters. AB is 14 centimeters. And we are asked to obtain the value of angle B. So as usual, we're going to use the sine rule because we are given two sides and an angle, and the given angle is not an included angle. So we're going to use the sine rule. Here is the sine rule. A over sine A equals B over sine B equals C over sine C. Now we can see that we've got lowercase b 12 cm, lowercase c 14 cm. We've also got uppercase C, that's the angle at C, that's for the asked to obtain the value of the angle B. So here we can see that we've got C and C, both upper and lower cases. We've got lowercase b and we're asked to find uppercase B. So we can see A does not come in here at all. So I'm just going to isolate A over sine A. So I'm only going to be using B over sine B is equal to C over sine C. Substituting the given value here, so I would have 12 over sine B is unknown, so that's just going to be B. Now C is 14 divided by the angle at C is 42 degrees, so this is just sine 42 degrees. Now I'm going to cross multiply. So if I cross multiply here, I'm going to have 14 sine B is equal to 12 sine 42 degrees. Dividing both sides by 14, so this is equal to 12. Of course, sine 42 degrees is 0.7192. So I'm going to have a 14 underneath. 12 times 0.7192 is 8.6321 divided by 14. So the division is going to give 0.6166. This is sine B. To obtain the value of angle B, I'm just going to take the inverse sine of 0.6166, and this is going to give 38.0683 degrees. So I could just approximate this corrects to 1 decimal place, and the angle at B is going to give 38.1 degrees. This is the value of angle B. So let's pick another example. Here we are asked to obtain the value of angle A. So clearly the sine rule is not going to work here because we are given 3 sides. We do not have any angle. So the cosine rule is going to work because one of the conditions for the cosine rule to work is when we have 3 sides. So since we are asked to obtain the value of angle A, then we're going to have to use, we can choose to substitute the values directly into the equation or make the cosine of A the subject. So that's what I'm going to do. The first thing here is to move 2bc cos A to the other side and A squared to the right side. So this is going to be 2bc cos A is equal to B squared plus C squared minus A squared. Dividing both sides by 2bc, so I'm going to get cos A is equal to B squared plus C squared minus A squared over 2bc. And I can as well rely on this approach to obtain the value of cos B. Of course, that's going to be A squared plus C squared minus B squared over 2ac. And I can do a similar thing for cos C. That's going to be A squared plus B squared minus C squared. This is lowercase c. This is the angle here. These are angles. Divided by 2ab. But this is what I need to solve this problem. So I've got A equals 13 cm. So this is A, lowercase a, that's the side facing angle A. Lowercase b is equal to 18 cm. And lowercase c is 9 cm. So I'm just going to substitute them right into this equation. So this is going to fetch me cos A is equal to B squared, that's 18 squared, plus C squared, that's 9 squared, minus A squared, that's 13 squared, divided by 2 BC, that's 2 times 18 times 9. 18 squared is 324, 9 squared is 81, 13 squared is 169, 2 times 18 times 9 is 324. 324 plus 81 minus 169 is 236. And if I divide 236 by 324, I'm going to have 0.7284. This is the cosine of angle A. What I need is angle A, not the cosine of angle A. So I'm going to take the inverse cos of 0.7284, and that's going to give 43.2476. And I could just approximate this correct to one decimal place, and the value of angle A is going to be 43.2 degrees. If you find this video useful, kindly like, share, drop a comment, and do not forget to subscribe. Thank you for watching. See you in the next video.